Hello, in this video, we'll continue the tutorial with rotation and displacement or shift instructions. Then we'll do a simple project to save data on the PLC memory. During the project, we'll see how a symbol table can be used, and also we'll review how a Delta PLC can connect to factory I/O through the OPC server by KepServerEX software. Before we get started with today's video, I just wanted to inform you about all the great content we have been releasing on the PLC Goods YouTube channel, which includes industrial automation PLC programming, HMI, and microcontroller-based developments. My name is Syed Reza, and if you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel. Note that rotation and displacement instructions can be found here. Like previous videos, each instruction has several forms. I will explain their basic form. Let's start with rotation right instruction. This instruction rotates bit status of the selected address at the first input to the right. The last bit will move to the first bit and also to the carry flag, M1022. The second input determines how many bits must be moved for one execution. Note that this instruction is generally used in pulse execution mode. Well, if the second input is equal to 1, and after one execution, PLC will change bit status in D10 and the carry flag to this state. Similarly, these are the result for n equal to 2, 3, 4, and 5, which is the final result of this instruction, if it's executed one time. Similarly, we can use the rotation left instruction to rotate bits to the left. The next instruction, RCR, rotation right with carry, works like the rotation right instruction, but the carry flag will be used inside the rotation too. These are results of this instruction, when n is equal to 1, 2, 3, 4, and 5. As you can see, this instruction uses the carry flag bit. So, this instruction rotates 17 bits instead of 16. Also, RCL instruction rotates stored bits in D10 and the carry flag, M1022, to the left side for n bits. Now, let's see how the SFTR instructions works. The first input specify the first address of a group of bit addresses. Similarly, these items determines a group of bit addresses. Now, if this instruction is executed, first, all bits will be moved to the right side for 3 bits, and then, these bits will be used to fill empty bits addresses. So, these bits will be moved here, and also, all bits will be moved to the right side. Note that, in this example, the 3 last bits will be lost. Similarly, the SFTL instruction performs a left shift on the selected bit addresses. The next instruction is WSFR, word shift right. It works like the SFTR instruction, but deals with addresses like D0, which have more than 1 bit. At this time, stored numbers in D0, D1, and D2 will be lost. Stored numbers in D3 to D9 will be moved to the right side, and then, PLC will copy stored numbers in D50, D51, and D52, to D7, D8, and D9. Well, WSFL instruction works in the opposite direction. During the project, I will use that to save a water tank level on the PLC memory, every 10 seconds. Let's continue with SFWR and SFRD instructions, which can be used to write data on the PLC memory, which usually is called stack memory, and read data from the stack memory. The first input of the SFWR instruction specifies an address, and these parameters determine the stack memory location. SFWR is used to write data on the stack memory. On another side, we can use SFRD instruction to read data. This type of memory can be used to store some initial setpoint or parameters, and then use them during an industrial process. Let's explain it with a simple example. As I mentioned, these parameters determine the stack memory, starting from D0. The first address we'll use as a pointer, its initial value is 0. Now, assume the stored number in D20 is 11. If I activate the SFWR, this value will store in D1, and D0 value will be changed to 1. Again, if I activate the SFWR instruction, the number 11 will store in D2, and the stored number in D0 will be increased to number 2. Let me change the stored number in D20. Now, if I use the SFWR instruction, the number 6 will be stored in D3, and D0 will be increased again. This process can be continued until the stack memory won't have anywhere to store data. For now, D0 is used as a pointer, and D1 to D9 to store data. Well, I can use SFRD instruction to use stored numbers. For the first time, the stored number in D1 will move to D21, and then, the stored data on the stack memory will move to the right side. This process can be continued until all stored data will exit from the stack memory. Note that, the last entered number, will be the last number, which will exit from the stack memory. Alright, usually each industrial process has some important parameters which must be saved regularly. These parameters can be analyzed to find why an error has been occurred, or can help us to make appropriate decisions. In this video, I want to use the WSFL instruction to save the water tank level on the PLC memory. First, let's test the final project, then, I will explain from the beginning. As you know, I'm using OPC server to connect my Delta PLC to equipment inside factory I/O software. Well, let me use the first switch to open the inlet valve. Now, my PLC receives the level meter signal to calculate the current water level. Then send it to the first digital display. Also, my PLC stores the current water level in 4 locations on its memory, every 10 seconds, and also, displays them on these 4 digital displays. As you can see, every 10 seconds, the oldest level will be lost, and the current level will be saved on the PLC memory. Now, let me close the inlet valve, and then, let's test the second switch, to open and close the discharge valve. Note that, even if I stop my PLC, these levels can be seen. Because I used latched memories to store them. Now, let me explain my PLC program from the first step. Until now, we usually use direct addresses in our programs. In this video, I want to write my program based on symbols, which can be defined inside the local symbols table. First, I need a symbol to receive the level meter signal from factory I/O software. I select D0 for this symbol. So, instead of using D0 address in my program, I will use this symbol. Note that, the level meter signal starts from 0 to 10, and its data type is real. I will use the level meter signal, to calculate the current level, and then, send it to the first digital display inside factory I/O software. So, let me create the symbol. Now, I select D2 inside the address column, and also word, for its data type column. Similarly, let me define 2 symbols, which will be used to open and close fill and discharge valves inside factory I/O software. Now, I want to define a new symbol, to store the current water level. Let me use the help window, to select a latched memory. Because I don't want to lose them, when the PLC is in the stop mode. Well, these are my PLC latched memory addresses. Let me use D512. Also, I will need to use a timer. Well, this name, timer, cannot be used as a symbol. Let's change the symbol name to timer1, and then select timer for its data type. Well, inside the program, I will need two contacts, to open and close fill and discharge valves. Now, I'm defining two boolean symbols. Later, I will connect them to the first and second digital inputs. Alright, in previous videos, I explained how DMOVR instruction can be used, to open or close an analog valve, which works with a voltage between 0 and 10. As you see, I am using the defined symbols, instead of using PLC addresses. Well, this program will open or close the fill valve, based on this symbol state. Note that, until now, I've not determined any address for this symbol. Now, I can complete my program, afterwards, determine these addresses. Let's continue. I need a similar program to open and close the discharge valve. Now, I want to multiply the level meter signal, which is a number from 0 to 10, by 30, to calculate the current level in centimeter. Note that, after multiplication instruction, I also need the int instruction, to change the data type to an integer number, to display the calculated current level on the first digital display. Well, here I need a memory address to save the multiplication result. I can write an address like D25, or define and use a new symbol. Now, I want to store calculated current value on the PLC memory, every 10 seconds. So, let me use a timer, with its normally close contact, to have a timer which is restarted every 10 seconds. After that, I will use the timer contact to activate a WSFL, word shift left instruction. Well, I use WSFL instruction to store the current level on my PLC memory. Now, I select the symbol at the output side, whose address, D512, is a latched memory. Note that, I want to use D512 address, and also its 3 next address to store water levels. So, at the second input I write 4, and at the last input, I write 1. Because I want to store one parameter. Note that, because of this contact which refers to the timer, PLC will use the WSFL instruction every 10 seconds. Alright, my program has been complete, but there is an important point. As you saw, I've written my program with these symbols. I assigned an address for these, but these 3 last address don't refer to any address. So, when I compile the program, PLC will select an appropriate address for them. Another important point is, I can easily change used addresses in my program. I only need select a symbol and change its address. I prefer to use my first and second digital inputs. Note that, based on the last network, my program will use D512 to D515 addresses to save the current level every 10 seconds. I've tested this program before. So, there isn't any special point to say. Other steps like using ComMGR software to download the program into my PLC, or use KepServerEX software to create an OPC server, and connect my PLC to factory I/O, were explained in previous videos. After now, I only review these steps. Now, my program is downloading. As you know, I can use this icon to activate the online mode. Now, let me run my PLC. As you know, we can see the program execution inside the PLC, when the online mode is activated. It can help us to debug our programs. For example, now, the timer is restarting every 10 seconds. So, it works correctly. Note that, I cannot use the online mode and OPC server at the same time, because both of them use the same serial port. So, let's close the ComMGR software. Well, the next step is create an OPC server using KepServerEX software. I've explained how a channel and also connecting tags can be defined. Now, let me delete it and create it again, to review it. Here are different devices and protocols. I'm using Modbus ASCII serial. After that, I use default settings, except this item to correct my serial port number. Now, I must define which data must be accessible through the OPC server. As I explained before, each addresses inside the program has an Modbus address too. It can be found inside this table. Well, if I want connect to the first created symbol, level meter with D0 address, I must use this Modbus address. Here, I select an appropriate name, enter the Modbus address, correct its data type, and also its scan rate can be changed. Similarly, let me define all necessary tags based on my PLC program, which must be shared with factory I/O software. Note that, I also need this address, D512, and its 3 next addresses, which are used to store water levels. Now, let me activate the OPC server. As you see, the connection quality is good. For example, I can use these two switch to send 10 or 0 to these parameters, which are connected to my PLC symbols. The next step is connecting these tags to equipment inside factory I/O software. Now, I must select the created OPC server by KepServerEX software, and then find define tags inside the OPC server. As you see, many tags have been found, but I only need these tags, which are started with Delta_D. Now, I am connecting equipment to these tags inside the OPC server. On other side, these tags are connected to symbols, which were defined inside the PLC program. Now, I can test my project. Alright, I've tested this project before. In the next video, we'll learn data processing instructions. Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel, such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.